In our last video, we talked about how to frame the null and alternative hypotheses. Once again, the null hypothesis is the hypothesis that says there is no relationship between our two variables x and y for a unit of analysis. And the alternative hypothesis is the one we are most interested in knowing about, where we specify that there is a relationship between x and y for a unit of analysis, usually specifying a direction such that as x increases, y increases, or as x increases, y decreases. So the challenge for evaluating the null and alternative hypotheses is that we're only collecting data usually for a single sample. That is, we are collecting what basically boils down to one piece of evidence. And from that one piece of evidence, we are trying to discern whether or not the null hypothesis is more likely to be true in the world, or if the alternative hypothesis is more likely to be true in the world. Now, the way I like to frame this, especially when I'm teaching the class, is to think about how criminal court works. So in criminal court, there are two hypotheses basically for every defendant. One hypothesis is that the suspect or the defendant is innocent of committing the crime. Essentially, that's the null hypothesis. We are saying that the suspect or defendant, we'll call that person X, is innocent. That is, they did not commit, or they are not related to the crime, which we would call Y. So the null hypothesis is basically the innocent hypothesis that says that an individual or a variable X is not responsible for influencing or creating an outcome Y. Just like in court, there's a second hypothesis, the one the prosecutors are looking to kind of demonstrate, and that alternative hypothesis that the suspect or defendant is guilty of committing the crime. For us in statistical analyses, that is the same as saying that our variable X is guilty or responsible for the values of Y. So the intuition is the same. We have an innocent hypothesis, the null hypothesis, and we have a guilty hypothesis, the alternative hypothesis. Now, the fundamental challenge that comes up is that we have a single piece of evidence by which we need to make a decision. So just like in court, we can make the correct decision or we can make an incorrect decision. Thinking kind of intuitively through this framework, if the suspect is really innocent, that is, the suspect did not commit the crime, and we find the suspect innocent, that is, we as the jury, based on the evidence, do not think that that person committed the crime, we've done a good job. We have set an innocent person free. And that sounds really, really great from a statistical and a legal framework. Similarly, if the person or the suspect did commit the crime, and we found, based on the evidence, the person to be guilty, then we have convicted a guilty person. We've also then done a good job. So if X is really responsible for driving Y, and we find that X is responsible for causing Y, we've done a good job in our analysis. But there are two possibilities for mistakes, both in court and statistical inference. The first mistake is that the suspect or defendant is in reality innocent, but based on the evidence, we conclude that defendant is guilty. Once again, in reality, X might not be responsible for Y. There might be no relationship between X and Y. But based on our evidence, we might mistakenly conclude that X, in fact, did cause Y or did commit the crime. In this context, we would have made an error. Our error would have been that we have convicted an innocent person, or we have found that an innocent variable is responsible for the outcome. That is, we have found a relationship where one does not, in fact, exist. In other words, we have convicted that innocent person. This is what we call in statistics a type 1 error, convicting an innocent person. And we find that type 1 errors are really, really bad, because if we start making decisions based on a type 1 error where we think a relationship exists when one doesn't, of course, negative outcomes can emerge for society. The most common example I use for this is that there was a study that was published that found that there was a relationship between MMR vaccines, measles, mumps, and rubella vaccines, and autism. And this study had falsely concluded that this link existed. The study was eventually retracted and no one could replicate it, and it still can't be replicated to a high degree today. So today we generally know from the scientific literature that there probably isn't a relationship between vaccines and autism, but a single study did conclude that there was this link. And today we're making decisions based off of that single study that made a type 1 error. And we're not vaccinating children. That's leading to a resurgence of diseases that were once eradicated in North America. So once again, if you think about the MMR vaccines causing autism as a type 1 error, you can think about some of the problems that have come up in society from that mistaken kind of inference about those two variables. So conversely, we can make another error. The other error is that we can actually have a guilty person, or we can have a guilty variable. In reality, X causes Y, or in reality, the defendant did commit the crime, and based on the evidence, conclude that the person is innocent. In that case, we would call that a type 2 error in statistics. A type 2 error is the equivalent of setting a guilty person free. Now, while type 2 errors are not desirable, we often tend to think that setting 100 guilty men free is better than convicting one innocent person, largely because the old adage goes that when you set those guilty people free, you can always catch them again later. There's another opportunity to evaluate their guilt, where it's a lot harder to go back once you found someone guilty and demonstrate their innocence. And so this holds true for statistics as well. So once again, type 1 errors are mistakes when we conclude that relationship exists when they in fact do not exist, and type 2 errors are where we conclude that a relationship does not exist when they do in fact exist in reality. Both of these outcomes, along with the two correct outcomes, can be summarized in a 2x2 table. So let's just briefly take a look at that table now. All right, so let's look at a table that showcases how we end up with type 1 and type 2 errors based on how the world really is and the decision that we make. Please note here that when we're talking about statistics, we are always talking in reference to the null hypothesis. So you won't see the alternative hypothesis mentioned anywhere when we're drawing our substantive conclusions, because we're basing our decision off of the assumption of the null hypothesis being true. So if you look at our table, in the columns we have the state of the world. The state of the world refers to reality, how it really is. What is the actual state of the null hypothesis? So in reality, the null hypothesis can be true or it can be false. That is, the person or variable can be innocent, X did not have an impact on Y in reality, or X could be guilty, X does cause Y in reality. In the rows, so in the left column, the leftmost column, we have our decisions based on the evidence. So based on the evidence, we can conclude to reject the null hypothesis. If we reject the null hypothesis, we are essentially rejecting someone's innocence or the variable's innocence. Rejecting the null hypothesis, therefore, concludes that X is responsible for Y or X is guilty. The other decision we can make based on our evidence is to fail to reject the null hypothesis. If we fail to reject someone's innocence, that means we think they are innocent. And I know it confuses students because it's kind of like a double negative. We fail to reject, but that's kind of the language we use in statistics. We fail to reject the null hypothesis. So once again, failing to reject the null hypothesis means we conclude that X is innocent of causing Y. Now, when we combine our decisions against reality, we have 4 possible outcomes. So in reality, if the null hypothesis is true, and this is the first cell on the top left, if the null hypothesis is true in reality and we reject the null hypothesis, then we have committed a type 1 error. That is, we have identified a relationship that does not really exist in reality. So the type 1 error, once again, is when there is no relationship, the null hypothesis is true, and we reject the null hypothesis and conclude that there is a relationship when there in fact is not one. Moving down to the bottom left cell entry, here we've got that the null hypothesis is true, so in reality there is no relationship, and we failed to reject the null hypothesis or conclude there is no relationship. If there is no relationship and we conclude there is no relationship, we've got it correct. We have not found a relationship because one really does not exist. Moving to the sort of rightmost column, here the null hypothesis in reality is false. So in reality there is a relationship. So looking at that top cell entry in the right column, if we reject the null hypothesis, and the null hypothesis is in fact false. That means that we have concluded there is a relationship when there in fact is one. So that is correct. We have found a relationship because a relationship does exist. And then finally, in that bottom right sort of cell entry, here we have, once again, that the null hypothesis is false. So a relationship does exist in reality, but we have failed to reject the null hypothesis. So we have concluded that X does not impact Y when in fact it does. That is a type 2 error where we fail to identify a relationship that exists. So really, most of statistical analyses and inference is based off of really figuring out when we're willing to make a type 1 error. We always want to err on the side of caution and not conclude guilty or not conclude there's a relationship. And we'll talk more about that threshold, which we call statistical significance, in the next video.